Hello everyone and welcome to another lecture in the sonography, physics and instrumentation, and today we'll discuss decoded excitation. Coded excitation is a sophisticated digital technology. Means that it's not easy to understand in our level, but we need to know some facts about this. It's engineered in the pulsar. The pulsar is created electric voltage pulse that is made of multiple frequencies and are transmitted with a digital encoding. Ultrasound pulse that is created from the transducer is having the same technology, which is encoded technology. The reflections that they reflect back to the transducer and then they are transmitted or carried to the machine, to the ultrasound system, through a lot of complex binary technologies and mathematical analysis. These reflections will be built again as an ultrasound image, but with the high superb uh, quality image. In coded excitation, there are three criteria for the generated pulse. The generated pulse that are coming from the pulsar has three criteria. Number one is a long pulse with modulated frequencies. Second, it has binary or digital encoding. Third, it has high output power. We'll discuss these one by one in a moment. First, we come to the long pulse with the modulated frequencies. If you look at here, this is the diagrammatic display similar to what happens with the coded excitation. If you look at here, it's made of different frequencies. And these frequencies are in a succession. So the generated pulse, that's the whole pulse length, is a long pulse. You can see here, all this is the pulse. So from here to here is the pulse. But this pulse is made of several frequencies. So the generated pulse is longer than the conventional B-mode pulse. We know that the B-mode pulse is nowadays within the range of 3 to 2 waves along the pulse. Now you can see here more than this. So it's a longer SPL, longer pulse duration. Includes a wide band of frequencies, as you see here, like this or this or this. All these are different frequencies in the same pulse. Somebody will say, since I'm having a long SPL, a long pulse duration, am I getting a deteriorated axial resolution? No, the answer is no. Because with this coded excitation technology, the axial resolution is depending on the separate or individual frequency, not the whole set of frequencies. Each one in separate will determine the axial solution. Second criteria of the coded excitation pulse that it is digitally encoded, or sometimes called binary encoded. It means that these frequencies are having, each one has a different digital code. So I'm having here these frequencies here, each one has a digital code. And this will help when the reflections come back to the transducer. These codes will be decoded and will form an image made of all of these frequencies. So with this digital encoding, okay, I will get better resolution because I'm having now multiple images, each made of several frequencies. I'm having some images made of the lower frequencies, mid frequencies, higher frequencies. So this will help to receive upon received in the receiver and that digital scan converter. This will be converted to a better image with a high resolution. The third criteria that the coded excitation pulse is having a high output power. Why they do this? Why they need a high output power? Remember, when I have a high output power, I will get strong signals, and so strong signals coming back, reflections, will overcome the noise. So I'm getting here a better SNR, a better signal to noise ratio. Somebody will say, okay, I'm having high output power, so I'm degrading now the bioeffects, or I'm encroaching about the bioeffects. This is harmful to the patient. Actually, no. Why? Because this output power is distributed along a long SPL, a long pulse duration. So the temporal intensity here is lower, although the total output power is high, but the temporal intensity is low. So I'm not affecting the bioeffects. So now we come to the echoes that are received back. We have discussed the echo transmitted, and we mentioned that the echo transmitted is a long SPL with frequency modulated. The pulse is digitally encoded, and it has a high output power. Now, how about the received echoes? The received echoes, they are a specific pattern, of course, and they need some series of mathematical and digital analysis. So at the end, I will get a better spatial resolution. Somebody will say, we just mentioned that we have a long SPL pulse duration, and this, we all know that this will deteriorate the axial solution. And as we mentioned earlier, okay, axial solution in the coded excitation depends on the fractional bandwidth of frequencies. So the the frequencies are fractionated, and they will get different axial solution based on each frequency. So the axial solution here is depending on the separate frequencies or individual frequencies, not upon the total SPL or pulse duration. So in general, what are the advantages of coded excitation? What are the benefits of coded excitation? It has a better SNR, it has a better spatial and axial resolution, better contrast resolution, reduced side lobes, and better penetration depth. Thank you, and see you later in another video. Have a good week.